Now applying the second equilibrium condition, it's very simple. We find out the resultant. Resultant R is equal to 0. This implies the first force, that is TBD plus TBE plus A vector plus this 4 kilonewton vector, 4 kilonewton, together becomes 0. So now when we summarize this, TBD can be replaced as 5.238 divided by 3.3, because this TBD value is found out as 5.238 kilonewton, and the respective unit vector is minus 1.8 I plus 2.1 J plus 1.8 K. That's the first term. Then the second term for TBE, once again, that is 5.238 only divided by 3.3. Then the unit vector is minus 1.8 I plus 2.1 J plus 2.1 J minus 1.8 K minus 1.8 K. Then the vector A is nothing but AX I vector plus AY J vector plus AZ K vector. The last weight 4 kilonewton is nothing but minus 4 kilonewton J vector, together it becomes 0. So now we compare the I term, J term and K term. When we add all the I term and equal to 0, we get one equation for I. Similarly, we get equations for J and K. Adding and equating all I coefficients, I terms, all coefficients of I terms equating to 0, we get the first term is nothing but this, that is 5.238 divided by 3.3 minus 1.8 minus 1.8. The second I term is this, that is once again plus 5.238 divided by 3.3 minus 1.8. Here is the third I term, that is AX plus AX equal to 0, equation number 1. Similarly, we take the J term. So that is nothing but 5.238 divided by 3.3. The jth term is, the coefficient for jth term is 2.1. Second one is once again 2.1. 5.238 divided by 3.3 multiplied by 2.1. Then we have the term AY, that is again plus AY. Once again you have the last term which has got only J value alone, so which is minus 4. So this can be equated to 0. We take the kth term. Here is 1.8, so that's nothing but 5.238 divided by 3.3. This is 1.8 plus 1.8 plus. Then we have 5.238 by 3.3, but 1.8 minus 5.238 divided by 3.3, 1.8 minus. Then we have the Z value K k to term as Az is equal to 0. So this is equation 2, this is equation 2. Look at all the three equations. You quickly understand these two are plus minus, so they cancel each other, will give you a simple value that is nothing but Az, which is equal to 0. Next, remaining two equations, when we look at, we have Ax in one side, this minus goes to the other side, you can very easily find out Ax. So from equation 1, Ax is nothing but 5.238 divided by 3.3 multiplied by 1.8. The whole value has to be multiplied by 2 to get the answer. Similarly, Az can be Ay from equation 2. We take Ay in one side, we make all the other term to the other side, we get minus 4 as plus 4, 4 minus, you have 5.238 by 3.3 multiplied by 2.1 twice, so therefore you can introduce that twice here. 5.238 divided by 3.3 multiplied by 2.1. This can give you the answer for Az. So we can just calculate this and quickly find out the answer for Ax and Ay. Answer for Ax is 5.238 divided by 3.3 multiplied by 1.8 multiplied by 2. We get the value as 5.714. This is 5.714 kilonewton positive. Then the second one, Ay as 4 minus twice 5.238 multiplied by 2.1 multiplied by 2.1 divided by 3.3 gives you a minus value, a negative value. So when we assume Ay as upward, we get negative value. So naturally Ay is downward. So it is minus 2.666 kilonewton. So the summary of result can be written here. We have the tension values, results, tension values TBD equal to TBE is equal to 5.238 kilonewton, and the A vector, which is nothing but Ax I vector. So Ax is 5.714 kilonewton I vector. Then Ay is minus, so minus 2. Naturally this 2.6665 can be approximated as 667 kilonewton J vector. For K value it is 0, so therefore we get 0 K vector, or even we can ignore this. This is the answer for this problem.